In this video, we are going to talk about rational functions. Now, a rational function is a function that can be written in the form n of x divided by d of x, where d of x is not 0, and n of x and d of x are both polynomials. So n of x is the numerator, d of x is the denominator. Now, there are a couple of things that we should talk about with respect to rational functions that's important for you to know. The first are horizontal asymptotes. So a horizontal asymptote describes the behavior of the rational function as x goes to infinity or as x goes to negative infinity, meaning what happens to the function as x gets really, really big and positive, or as x gets really, really big and negative. Now, if the function approaches a line, y equals a, so that's a horizontal line, as x goes to infinity or as x goes to negative infinity, then the line y equals a is said to be a horizontal asymptote of the function. Here's an example. The line y equals 0 is a horizontal asymptote of the function f of x equals 1 divided by the quantity x minus 2 squared. And you can see from our graph that as x gets really, really large, in this case not very large, but as x gets really, really large, the function basically becomes 0. And if we think about this function, if we plug a large number in for x, say a million minus 2 is still about a million. We square that, that's a really, really big number, and 1 divided by a really, really big number is a very, very small number. So as x gets larger and larger, the function becomes closer and closer to 0. And this is true whether x becomes large and positive or large and negative. This function, x cubed divided by x squared plus 1, does not have a horizontal asymptote. And you can see this function does not approach some horizontal line as x becomes large and positive, or as x becomes large and negative. This function actually has what's called a slant asymptote, but we don't need to know that for this course. To find a horizontal asymptote, we have three possible cases. Case 1, if the degree of the numerator is smaller than the degree of the denominator. Remember, the degree of a polynomial is the power of the largest power for a term. So if the degree of the numerator is smaller than the degree of the denominator, then y equals 0 is a horizontal asymptote. If the degree of the numerator is equal to the degree of the denominator, then y equals a over b, where a is the leading coefficient of n of x and b is the leading coefficient of d of x, as in the coefficient of the largest term. If the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. So if we go back and look at those functions we just looked at, the degree of the numerator is 0, the degree of the denominator is 2, that means y equals 0 is a horizontal asymptote. The degree of the numerator for this function is 3, the degree of the denominator is 2, and that means this does not have a horizontal asymptote. So these are our rules for horizontal asymptotes. We also talk about vertical asymptotes. So a vertical asymptote of a function f of x is a vertical line to which the rational function approaches as x gets close to the line. The function is not defined at the vertical asymptote, and the function value tends either towards infinity, becomes very large and positive, or negative infinity, becomes very large and negative. So if we look at this function, we can see the line x equals 2 is a vertical asymptote of the rational function f of x equals 1 divided by x minus 2, the quantity squared. So we can find vertical asymptotes as follows. Given a rational function f of x equals n of x divided by d of x, where again d of x is not equal to 0, we have two cases. If n of x and d of x have no zeros in common, then all zeros of d of x are vertical asymptotes. So remember, So to find vertical asymptotes, we can do the following. Given a rational function, f of x equals n of x divided by d of x, where d of x is not equal to 0, we have two cases. Case 1, if n of x and d of x have no zeros in common, then all zeros of d of x are vertical asymptotes. So what does that mean? A zero of a function is an x value for which that function is equal to 0. So if d of x is equal to 0, let's say at some value a, then x equals a is a vertical asymptote. Now case 2 is if they do have zeros in common, then we need to factor the numerator and the denominator and simplify the function. Once we've simplified the function, then we use case 1. So let's do some exercises. So we want to find the equations of the vertical asymptotes for f of x equals x squared plus 1 divided by x squared minus 1 times x squared minus 9. So horizontal asymptotes. We look at the degree of the numerator and the degree of the denominator. The degree of the numerator is 2. The degree of the denominator is 4, right? That's going to be that x squared times this x squared will be 4. If the degree of the numerator is less than the degree of the denominator, then y equals 0 is a horizontal asymptote. For vertical asymptotes, we need to do a little bit of work. We need to factor out this denominator. The numerator we don't have to factor because it cannot be simplified any further. So we take f of x, we'll factor this, x squared plus 1 divided by x minus 1, x plus 1, x minus 3, x plus 3. And again, I've just done this because I recognize these two equations as the difference of two squares, and this is how you factor the difference of two squares. None of these zeros, 1, -1, 3, and -3, are zeros of the numerator, which means they are all vertical asymptotes. So the vertical asymptotes are x equals 1, x equals -1, x equals 3, and x equals -3. Okay, let's do another exercise. Again, same problem. Find the equations for any horizontal and vertical asymptotes for f of x equals 3x divided by x plus 2. Okay, horizontal asymptotes. The degree of the numerator is 1, and the degree of the denominator is 1, which means that y equals the leading coefficient of the numerator, or 3, divided by the leading coefficient of the denominator, 1, which is just 3, is our horizontal asymptote. Vertical asymptote, we look at the zeros of the denominator, just x equals -2. That is not a zero of the numerator, which means that x equals -2 is a vertical asymptote. Now on for our last problem. Same thing, find the horizontal and vertical asymptotes. We've got this slightly more complicated function. We're going to think about our horizontal asymptotes first. We look at the degree of the numerator. That's going to be 2, 1, so 3. Degree of the denominator, 1. If the degree of the numerator is bigger than the degree of the denominator, there are no horizontal asymptotes. And now we think about vertical asymptotes. Okay, the vertical asymptotes, we need to do a bit of factoring. So f of x equals, and I can just see the factors for this equation, but if you can't see them, then I would use the quadratic formula. So that's going to be x plus 3 times x plus 1 times x minus 1 divided by x plus 1. Now, the 0 of the denominator, -1, is also a 0 of the numerator, so we simplify, cancel out these two terms, and we get x plus 3 times x minus 1. I'm just going to multiply this out, so that's going to be x squared plus 2x minus 3, where x is not equal to -1. So again, we have, and maybe I should put my denominator in, 1. We have no zeros of the denominator, which means there are no vertical asymptotes. This function is just a parabola, or it's almost exactly the same as this parabola, except that it's not defined at x equals -1, which means there is a hole in this function.